Hi everyone. In this video, I'm going to go over a concept called visual acuity. So first, let's start off by defining what is visual acuity, right? So visual acuity is defined as the ability to differentiate between two stimuli. So it's basically, let's take a different color. Okay. Ability in simple terms to see two different things, to distinguish. Distinguish two things apart from each other. Each other. Okay, so first what we're going to do is we're going to have a quick anatomy lesson. So first thing we're going to go over is the retina, right? So the retina is the most furthest back piece of tissue in your eye, right? So say this is your eye. The furthest one back is what's known as your retina. And your retina is almost like, I'm not sure how many of you can relate, but in school, when you have a projector, your projector will project onto a blank screen, right? So it's almost quote unquote blank, not quite blank, but it's like a screen almost. So let me just cross out screen because it's not a blank screen, but it's a screen that gets projected onto, right? So a screen. And in this case, your projector will be your lens, right? Because your lens receives the image and it will project onto the retina, which is your screen. So then what's important to know about your retina is that it actually has 3 layers. So the 3 layers each contain different types of cells, right? So what's really weird about this is, right, is you'd assume that first let's go over the different types of cells, right? Basically, and once you understand why, you'd understand why it's a little bit weird, right? So basically, there are 3 types of cells in your retina, right? So 3 types of cells. Okay. First type are photoreceptors. Receptors, which are basically receptors of light, right? As it says, photo means light, receptors means receptors. So they basically understand color and lines, oops, lines and slash edges and their orientation, right? Orientation. Okay, so then the next type of cells are known as your ganglion cells. So your ganglion cells are basically the receptors for light and depth, right? So for the perception of depth and actually clarity as well. We'll get more into why this is, but clarity. And these are often the cells that preserve a visual map, right? Visual map. And then the third type of cells, so I'll explain visual map later, but I just realized that seems a little confusing, but I'll get into it, trust me. So then you have bipolar cells and amicron cells. Amicron, amicron, amicron. Amicron. So these are actually really interesting cells because they actually have no function. Well, they have a function, but it's not as specified as photoreceptors. So they're a type of neuron called interneurons, right? So interneurons. Neurons. We love interneurons. And the funny thing is, these don't have any other function but to basically act as the messenger between two types of cells, right? So now let's get into what we think the order is, right? So to me, what makes the most common sense is that photoreceptor should be first, followed by bipolar cells, and followed by the retinal ganglion cells because of one key piece of information, right? The axons of ganglion cells all make up the optic nerve, right? So I'm going to abbreviate that as ON. And the optic nerve exits through the back of the eye, right? Like so. So that's what makes the most sense, right? But actually, it's flipped. Your photoreceptors are at the back of your eye. So this is the order in which it goes, right? So it goes, say this is your back and this is to forward, right? So your photoreceptor cells are at the back, right? So these provide all the color information, all the other information, all the color and how the edges are oriented, right? So say this, I draw this line. There are specific photoreceptor cells called rods, which are actually rectangular right here, and they perceive the orientation as well as the orientation and the dim and light, right? So like how you see in dim light, that's what rods do. And colors are perceived by cones, right? You can see that they're kind of cones shaped. But anyway, so rods, your photoreceptor cell, your rod will see, oh, this is horizontal edge. And what it will do is it will send it to the retinal ganglion cells. So now here is where two different types of ganglion cells come into play, right? You have either the one that perceives light, the one that receives information, or the one that actually pertains to seeing depth, right? So one type of ganglion cells is just literally responsible for receiving photoreceptor information. And these kind of play a role in creating a 2D image, right? So the ganglion cells will form a 2D image. Then what you have are your other types, which are basically tiled across the retina. So basically say that this is one segment of the retina, right? What your ganglion cells will be like is they will be tiled, right? So like so. This is one cell, one cell, one cell, right? And then what you have is in each one, your receptive field is like so. It's a donut and it's shaped literally like a donut. Like you have your outer circle and you have a little inner circle as well, right? So what's really interesting about this is these type of ganglion cells, what they perceive is they perceive the depth, right? So basically, what happens is if light hits the exact center, right? Then you'll be able to see if it hits the center, then the whole cell gets activated, right? But if it hits the edge, right? If it hits the edge, then it's not activated at all. So the edge, it's not activated at all. But if it hits both the center and the edge, then it's weakly activated, right? Weakly activated. So what does this mean, right? Is this allows for edge detection, right? So basically, when I see a defined edge like this, if I see this, like when I see a straight edge, that means that my circle, my center is activated because I can distinctly see the line. But say I see some really, really fuzzy image, right? Or like I basically just see a blob. That means that I'm not seeing I'm seeing something really weak, which means both my center and my center and my edge are activated. But if say I don't see an edge at all, what that means is that the edge was hit, right? So basically, oops. How about we go back, please? Sorry. Okay, so what this means is that these ganglion cells are responsible for edge detection. So, all right, so what, you ask, right? So what is that? Now let's move on to how your ganglion cells receive it, right? So each of these ganglion cells receives a different amount of bipolar cells as an input, right? Like so. So visual acuity is known as your ability to distinguish two different points, right? So based on the number of inputs that a retinal ganglion cell receives, say it receives the retinal ganglion cell, this is a ganglion cell, by the way, receives only one input. That means it only has to process one input, which means you're able to see it more clearly, right? But say you have multiple things coming in, that means that you have to process multiple inputs, which means that you have to process more, which means that your distinction starts to muddle. So your distinction starts to go down. Can you kind of guess where this would be applied? Well, if you guessed peripheral or central vision, you'd be correct, because that's what happens in peripheral vision. In your retina, the more close to the center you get, so the center of your retina is known as your fovea, where cones and all your photoreceptors are highly concentrated. And the region surrounding it is known as the macula, right? Where cones are kind of densely concentrated, but not as much as fovea. The closer you get there, the higher your visual acuity is. That's why your fovea is used for fovea and macula. Actually, macula, more accurately, is used for driving and reading, right? It's used for driving and reading. But as you get further and further away from the center, the number of photoreceptors that each ganglion cell receives starts to increase, which means that the more you have to process, the less effort you can put into each individual task, right? So just think about it in terms of common sense. If you're given one task and you're given one amount of time, you're able to do it really, really well. Whereas if you're given like multiple tasks at once, you're only going to give half effort to each of them, right? So it's the same thing for these cells. So the more inputs each ganglion cell receives, the less clearly it will be able to distinguish between each one, which basically means that peripheral vision is based on the number of inputs you can receive. So to recap quickly, first, we talked about the different types of cells present in the retina. Those are your photoreceptor, ganglion, and interneurons, right? So photoreceptors actually receive all the information, right? Like the color and the edges. And the ganglion cells perceive depth and contrast, right? So the ganglion cells receive input from photoreceptors, and what they allow the photoreceptors to do, or they allow your brain to do really, is it allows you to see the 3D version of it, right? If your photoreceptors produce your 2D image, your donuts on your ganglion cells will allow you to put a 3D lens to it, right? It'll allow you to see the contrast between two of them. So if it hits the center, it gets activated, which means you'll see the edge very clearly. But if you don't see it, if it's kind of there, but it's kind of not, it means it hit both the edge and the center. And if it hits, you can't even see a line there. You can't really see an edge. That means it hit only the edge, right? And so basically how this adds up is that the number of inputs per ganglion cell basically allows you to distinguish between one or two more clearly or less clearly, right? If you receive more inputs to one ganglion cell, then your acuity goes down. You won't be able to identify as much as if you were to receive less amounts of inputs, right? If you receive fewer amount of inputs, you can distinguish more clearly, right? So yeah, that's it for this video. Thank you so much for watching. If you have any questions, please feel free to put them down below. And yeah, thank you so much. Have a nice day. Bye.